All right, so today we're going to have a video basically on box plots. Now, I know some of you guys just take notes from the video and you don't print my file that goes with it, but I do want to point out, I will be putting this on the whiteboard, but there is in the Canvas file right before this video link a really neat handout of lecture notes for most of what I'm going to go through. But most importantly, we're going to be practicing a data set, and that data file is in the lecture notes for this video. So you really do need or have it open that survey sheet. There are two different survey sheets that I use in various videos, so I do try to load it to the one that I'm using. So we've come off of mean and median, right? And we talked about how the mean is only good for unimodal and symmetric distributions. We talked about the median is good for skewed distributions. We also looked at how the mean and median relate to, our various smoothed out histograms, right skew, left skew, unimodal, all of that. And I also may have made mention that, particularly for house prices, because we know that that is skewed, that a lot of times newspapers do the correct thing. They will talk about the median home sales as opposed to the mean. So I complimented newspapers at that point, but I'm going to go back on that now. So let's start with this. And I just wanted to, depending on which class you're in, which chapter we're in. So let's look at, let me draw first. I can never write and talk very well at the same time. Okay, so I've tried to draw two unimodal and symmetrical distributions, and I wanted them both centered at the same thing, so thus the mean and median are the same, right? Mean equals the median, and it's the same for each curve, so I didn't want to have to worry about whether I was talking about the mean or median. But, I don't know. Let's just pretend that you're trying to search the internet for a starting salary for whatever your particular career is. Most websites, well, first of all, if they're doing the correct thing, they're going to give you the median and not the mean. But let's just go with that, right? You read that and you're like, oh, I'll make about $45,000, and you can start making your budget for your rent and whether you can afford a new car, whatever the situation is. The problem is most websites do not tell you anything else besides the mean or median. They do not give you a picture from where that mean and median came. So let's just say if this were centered at 45K, your expected starting salary. Which picture do you hope that number came from, right? What's the difference here? This one is more spread out, right? It is more variation. That's the formal word. This is what I call personally the gambler's curve. This one, because sure, you can make 100,000 just as likely as you're going to make 10,000 and you're going to have to be moving back home to live with mom and dad, right? You can make anything. This is not useful at all. Less reliable. Now look at the top one. Sure, you might make up to 50,000, or you might make lower, down to 40,000. And if you're making 40,000 and you were expecting 45, you just have to tighten your budget a little bit. Maybe stop online spending or something. No big deal. This one could be detrimental. So this one is more reliable, less variation. So the whole point is, if you're given the mean and median, that is actually useless information. It could be actually dangerous because you're going to assume you know a lot more information than you do. You have to be given a measure of spread or a picture, right, which shows you the spread. Let me write that. Okay, so you have to be given the measure of variation or a picture. The mean gets paired with something called the standard deviation. If you're in Math 307, there's also something called the mean absolute deviation. All of that's going to be covered in another video. The median gets paired with something called the IQR, and this is what we're focusing on today in this video, plus our fourth numerical graph. So you have to be given the variation along with the measure of center to be able to have the full story and all the knowledge that you need. All right, so again, if you want to not take notes, I really would encourage you to print this piece of paper, but I am going to write this stuff up on the board. So what is this thing called IQR? Well, it stands for interquartile range, okay? And what does that mean? Well, Q3 minus Q1, but if you don't know what those things are, that's not helpful. But only, and this is the standard notation. This is what almost all of the calculators use, but I do know that some books will use this notation, so I want to mention it. It's hard for me to say. UQ minus LQ. UQ stands for the upper quartile. LQ stands for the lower quartile. Okay, so what are the Q1s and Q3s? They're all about medians. This whole video is about medians. Q1 is the median of the lower half of the data. Q3 is the median of the upper half of the data. It's probably easier if you kind of just draw a little picture. Remember last time, or some video, we said the median cuts the data in half, right? And medians, of course, you would have had to put all your data in order first. And we said that was 50%, that was 50%. Well, we're cutting it in half again. So you have these little 25% pieces, right? Q1 cuts the lower half in half, Q3 cuts the upper half in half, and that's why they're called quartiles. Sounds like quarters, right? Because 25%, 25 cents, quarter, it all makes sense. Now, a few things here. So, IQR is Q3 minus Q1. So it's actually that distance, right? A lot of people will just call it the middle 50% because they know that most people don't know what IQR stands for. While we're here, let's get a couple more synonyms though, because something that you not only need now, but you're going to need for the rest of my course, no matter which course you're in, is the word percentile. That special word with the ILE on the end, right? And percentile is the percent of people that scored below you. So look at Q1. There's 25% below. So Q1 can also be called the 25th percentile. Q3, there's 75% below it. So Q3 can be called the 75th percentile. Again, these synonyms are really important, okay? You're even going to see me asking things like this on that dentist handout, and a lot of students forget that I gave them other ways to, other words to call Q1 and Q3. Now, this whole middle 50%. First, since we're in medians, we know it is resistant to outliers, right? Unusual values, we already talked about that. Because think about it, even the IQR, of course, is resistant. This is the middle 50%, right? You could take that upper 25% and add 1 trillion to each data point. It's still not going to affect the middle 50%. You could take that 25% and move them all down to 0. Still not going to affect this middle 50%. And of course, well, JMU, but all colleges, they know this, right? They know the appropriate way to talk about statistics. So, you know, when you were coming to JMU, and maybe you took your SAT score and you were wondering if it was good enough to get into JMU or whatever, you may have pulled up on the website some statistics from JMU. I have not pulled it up, so I'm going to totally make up numbers now. But JMU does make sentences. They'll say something like, for example, the median SAT score is 1,100 and the middle 50% score between 1,000 and 1,200. So they won't say the IQR is 200 because they know that parents and high school students don't know what that means. They'll say the median is 1,100 and the middle 50% score between 1,000 and 1,200. From that sentence, you're actually given Q1 and Q3, and you could actually calculate the IQR if you wanted. In that case, it's 200. But they're hoping from that sentence that people can figure out, oh, okay, 25% of students make higher than 1,200. 25% of students make lower than 1,000. So they're trying to give the information knowing that people probably haven't taken a stats course, but they are giving you all the information correctly, and I'm sure all colleges do that, right? So this stuff is really important. This stuff, though, also feeds into our fourth numerical graph. And this is really important that you do what I say, okay? The box plot that I'm showing you is technically called the modified box plot. That's really important because if you start Googling or going to a lower level textbook, or I don't even know what Khan Academy has, to be honest with you, they may not be doing everything that I expect you to do in my course. We're doing a modified box plot. I'm going to give you the template in just a second. But I'm not only supporting our SPSS statistical package that JMU uses, biology and all the sciences. I'm also supporting anything, let me rephrase that, anything I ever do in my classes. I am taking 80% of what statisticians agree is the appropriate thing to do. So that's how I always present material to you. Now I know when my own students were doing, my own daughters were doing this, in Virginia at one point it was in 6th grade, then it moved to Algebra 1. Anyway, they were not doing this full box plot that I'm going to show you. Sometimes it gets watered down in middle school depending on what grade they're teaching in. That all depends on the Virginia Department of Education, all that mess, right? So even if some of this looks familiar, I might be doing more than how you ever learned it. Honestly, I don't know what they do in Math 105. So all I'm trying to say is do what I'm showing you here. Oh, I know what I want to say. Historical accuracy. There was a man named Tukey. You don't have to know that. He's the one that developed this exact thing I'm going to show you, the modified box plot. Because historically, people used to just give their opinions on whether a data point was unusual, an outlier, too high or too low, right? But there was no standardization of that. So Tukey wanted to come up with something that everyone could agree on. Specific criteria that if a data point is higher than this, we'll call it an outlier. And then also, though, he wanted to do even more than that. He wanted to distinguish basically, were you just a little bit out there or were you a lot out there? He wanted to distinguish between what's called a mild outlier and an extreme outlier. So you're going to see that on here too. Here is the template. Again, it's on that handout. I'll move my plant a little bit. Okay, so there's a box, right? The left side is labeled whatever your Q1 is, right? Whatever number from the data set. Right side is labeled Q3. The median is wherever it is. I purposefully put it off center because a lot of students think the median is the middle of the box. It is not necessarily. The median is going to fall wherever it falls, okay? Now, the whiskers are the very last thing to do, so I'm not going to talk about those yet. We have these, a lot of books call them invisible fences. You could think about them as goalposts or hurdles, whatever. So these formulas, I had to write them kind of big so you could see them, right? I am labeling the fence, not the white space in between. So I am actually labeling the fence. So this is criteria. Oops, I forgot to write that, sorry. This is mild, this is extreme. Mild, extreme. So if a data point falls past this fence, he is definitely an outlier. But we're going to need to check, is he mild outlier or extreme outlier? So then we got to check this fence. If he falls past this fence, he will be called extreme. These formulas, Q3, they both start with Q3 plus, right? Because that makes sense. We're going bigger than Q3. This ending, this is what Tukey came up with. It's just a formula you're going to memorize, right? 1.5 IQR. And this one says 3 IQR. Remember, I gave you the formula for IQR just a couple minutes ago. It's Q3 minus Q1. You'll calculate IQR, you'll times it by 1.5, you'll add it to Q3. Here, you'll calculate the IQR, times it by 3, add it to Q3. Now down here, though, you might have low outliers. So I'm going smaller than Q1. So it makes sense that both of these start with Q1 minus. But the endings are the same as the endings up here. So these are Q3 plus, this is Q1 minus. That makes mathematical sense. So there's the generic template. Maybe I should write in red. Let's say you identify that you have some extreme outlier and on the high end, and that you have a mild outlier. You don't always have outliers, right? Depends on the data set. But in this case, we've used up the 2 highest data points as outliers. Look at what I wrote for whiskers. Whiskers extend to the highest or the lowest points that are not already outliers. So if you've taken your 2 highest data points and you've labeled them as outliers, well then the end of the whisker, right there, is going to get labeled as the 3rd highest data point, okay? Let's say you check down here and you don't have any outliers. Well then that whisker would get labeled with the minimum. So again, that's why whiskers have to be done at the very end, because you don't know what the end of the whisker is. Usually students prefer if I say it like this. Whiskers cannot cross your fences. You're not going to take that whisker all the way up to there. And this technique is called the modified box plot. We're going to practice a full one with the data set in a minute. But before I do that, let me do 2 more things. First of all, you don't label every single data point on a box plot. You're only labeling the critical ones, the ones that I've put on this template. You label every outlier there is. But then just the ends of the whiskers, Q1, median, Q3. In a testing situation, you do have to make sure you tell me what these fences were so I can check to make sure you calculated them properly, right? Now, remember when we were talking about means and medians, we talked about skew, right skew, left skew, that type of thing. Personally, I prefer to identify skew by looking at a histogram or maybe a stem and leaf. I find it kind of easier. Sometimes, now remember, if I say sometimes, that means not all the time. Sometimes you can easily identify skew from a box plot, and sometimes you can't. So it is test appropriate. If it's an easy one to identify, then I will ask you. So I'm going to give you a list of clues, and if they're all there saying the same thing, then you know that that's one I could ask you to tell me the skew. So let me put that up. And this is being able to tell it off a box plot, because that's our topic, right? I'm going to tell you the clues for the right skew, because for whatever reason, most of the data I do with my classes, if it's going to be any type of skewed, normally it's right skew. I mean, every now and then you'll see a left skew, but if you wanted to check left skew, you can just take my clues and switch it, right? The first clue that you have right skew is that that upper right whisker is going to be longer than the left whisker. The second clue is, where's your median located in that box? Is it on the left-hand side of center of that box? Then that is a clue for right skew. And then if, because there's not always outliers, right? But if there are outliers, they better be on the right side, or that upper side, right? Now, if you're looking at a box plot and if any of these clues contradict each other, that means I'm not going to ask you, because in real life, that means, yeah, I don't know what it is. I'm basically going to look at a histogram and not the box plot. But if these clues are all agreeing with each other, then that is what we would call a clear one that I would ask you about. Okay, so we're going to practice one, start to finish. This, of course, was real data from, which one am I using today? This was real data from a couple of years ago, I guess 2 years ago at this point, from my Math 220 class at the time. It was going to be too complicated to collect real data from you guys this semester, so it was easier just to pull some real data from the past. We are going to do, maybe I should label this. This is the spring 2018 Math 220 data. And we're about to do a box plot on Instagram. And I do even have it written, but in case it gets cut off when you print or something, we're going to omit the zeros. I'm going to make a brief comment on that. But, so, here's the data sheet I'm talking about. Now, I did label things here, so let me tell you. What's on the left was actually by person, right? You guys probably don't care because we don't even know who the people are. That was too much to look at in a classroom situation or now a video situation. So what I did was I took every column and I ordered them over here. So the data on the right is no longer by person, it's just by the variable. So it's a repeat of the data over here, just in a different organizational pattern. So always look over here on the right-hand side. Instagram followers. Now you'll see some zeros here. When I first asked this, these survey questions, the questions basically were, how many Instagram followers do you have? How many Facebook friends? How many Twitter followers do you have? I purposefully asked, well, basically bad questions because I wanted to be able to talk about it briefly now. In real life, I would have worded the question, do you have an Instagram account? Question mark. If yes, how many followers? If no, skip this question and go to the next. That's the appropriate way, but I did not do that. So I did have some students who left it blank because they didn't have an Instagram account. Or I had some students write an NA, meaning not applicable, and that was fine too. But I had a lot of students who actually wrote zeros, and I'm not convinced that they actually have an account, but they have 0 followers. For the college-age kids, it usually meant they didn't understand my question, right? So it's really important when you're asking survey questions to ask them clearly. Now, why would, in real life, someone have an account but have 0 followers or 0 friends? Well, there's lots of reasons. Maybe they just started it. Maybe they did it because a class required it. Maybe they needed a presence so they could follow news people and celebrities, but they actually don't want any followers themselves. They're not using it for the social aspect. Lots of reasons why someone might have an account with 0, but I find with my college students that's not the case. So anytime, whether it's histograms or box plots, when we're using my real data sheets, you are going to eliminate those zeros. You can just cross them off. You are not using those. And I even mentioned that right down there. So what I need you guys to do right now, and we're going to do it together, make sure everybody knows how to use their calculator. We're going to type in the Instagram. We're going to, isn't that what I'm doing? Yes. We're going to start with 242, go all the way down to 4186. Let me get you started. Then you can pause the video while you actually type all those in. So, grab your calculator. Turn it on. I'm trying to clear my screen. Okay. You're going to go find the Stat button. That's a really important button we'll be going to a lot. Stat. You'll see Edit, Calc, Test. Right now, we need to put data into our calculator, right? So you're going to go to Edit. Now, you can tell I already have data in. So I'm going to use my arrows, and I'm going to up arrow so the L1 is actually highlighted, see, above the horizontal line. Don't hit delete. If you hit delete, it will make your entire column disappear, and then I'll have to show you how to get back. Hit the clear button, but nothing happened. Hit enter, and it cleared it. So you want to get up to the top, hit clear, then enter. Now type in the number. You're going to go 242, enter, 308, enter. Pause me, type in that data set, then come back. All right, so I assume you have typed all of that. Now, how do we get the stuff that we need? So now you're going to go to Stat again. Now you're going to go over to Calc for Calculate. And see the first one var stats? I want you to hit enter exactly 1 time. Don't you dare hit enter twice. Again, that's a very bad habit from high school. I want you to hit enter 1 time. Okay, now this is where old calculators versus new calculators are going to look different. So let me start with the old calculator people because theirs looks like mine right now. We have the calculators that are unintuitive. See how it's just blinking at you, the cursor? You have to know what your calculator wants from you. It wants to know where did you put your data. I put my data in L1. So you're going to go second function of the number 1 makes an L1 come up. So now you have what I call a complete sentence. var stats L1. Because there's a lot of times you might want to be doing some analysis on L3. The problem is if you don't type that in, the L1, and you just hit enter, the calculator always by default is going to do L1. And what if that's not what you wanted? So I'm trying to break a bad habit, and I'm trying to always get you to think, where did I put my data? Okay, I put it in L1, hit enter. Oops, what did I do? Oh, I didn't. I was lazy. I didn't type the data in, did I? Let me get some other data up so I can show you at least what it should look like. Don't look at my numbers, okay? I just want to make sure you know that you should be seeing X bar, sum, all that stuff, okay? New calculator people. When you hit the enter 1 time, you probably don't even need my help because yours is intuitive. It says X list. Make sure that it says L1. If it says L2 or L3, you're going to have to go second function of 1 to make the L1 come up and then hit calculate. New calculator people or throughout this course, sometimes it will say frequency. That should be 1. You should never have to change it. So if that's coming up, make sure you do that. All right. Now, when you have your output, please know that there is more than what you just see. You'll see x bar, that's the mean. You'll see sum of x squared. We don't really need those. We should probably never be looking at that. You'll see Sx and sigma x. Please let me make a comment. On a future video, when I talk about standard deviation, this is where we're going to be getting the standard deviation. So, but we're not doing that for this video. But there is more output. Hit your down arrow about 6 times. Now you're going to see the stuff that we need for the box plot. You'll see the min, Q1, median, Q3, max. What do you need for the box plot? This is what you need for the box plot. I know when we do the dentist handout or when you do it, I think one of the pieces does ask you about the mean. Well, you would need him, but you don't need any of that for what we're doing right now, okay? So I'm going to get rid of that. That's what you need. Check your numbers. If your numbers are a little bit off, that means bad data entry. Go back to your L1 and figure out what number you did not type in properly, okay? So, before I start doing my box, there's some, what I call side work, scratch work, whatever you want to call it, that I know I'm going to need. IQR, Q3 minus Q1, should give you 619. I know that at a minimum, I'm going to need to know what 1.5 IQR is, so might as well calculate that right now. I'm just timesing 619 by 1.5. Do not round that. That is 928.5. It is not 929. We keep decimals in my class. All right. Let's do the box. Now, you're not going to label Q1. You're going to actually label the number, right? Okay, and I'm labeling Q3. Maybe before I keep going, this is probably the only graph that I do not expect that you show me to scale, because if you were doing this on a piece of paper, it's going to be nearly impossible to know like how far out those fences are and stuff. So we're just labeling everything. Now on this one's going to hurt my brain. I need to know where to put the median. Basically, this is what you need to know. Is it directly dead center? Is it somewhere to the left or somewhere to the right? A lot of times you can eyeball it. That one's kind of close. I don't know that I'm going to eyeball that. So how would you figure out what the center of the box is? Think midpoint in algebra or geometry, or think the average, right? If you average those two numbers, it's going to tell you what the middle is. 1158.5 plus 539.5 divided by 2. Well, let's see what that is. Sorry, I didn't write it down. 1158.5 plus 539.5 divided by 2. 849 is the middle. So I now know that 796.5 must be to the left. And I'm probably exaggerating where it is on the left just so I can remember that, right? Okay. Now we got to check our fences. This guy, Q3 plus 1.5 IQR should give you 2087. Now, you don't have to show me this work. I mean, it's helpful, so if you make a mistake, I have some partial credit to give you. But you got to show me what that fence is. And then I look at my data set. I'm literally, just to let you guys know, I'm looking at my data set right here. And I'm like, oh yeah, I do have data points bigger than 2087. So I definitely have outliers. Well, I don't know if they're going to be mild or extreme, so I absolutely have to do this fence. 1158.5 plus 3 times IQR. I don't have any help here, so I have to do this whole formula directly. 3015.5. Now this is where, to get the most out of my class, the entire semester, don't just trust me when I say 3015.5 and assume that you're going to be able to put that into your calculator correctly. I can't tell you how many students do bad order of operations on their calculator. So when we're doing stuff like that, put that into your calculator yourself and make sure you get that out so you'll know that you're okay with how to use your calculator. All right, so now I'm going to look at my data set, and I'm going to, because it's in order, so I'm starting at the top. 4186. Oh, he must be extreme. So let me put my little titles. Okay, you're going to label, and you're going to label him 4186. 2435. Oh, he must be in here. 1402. Oh, he's not an outlier. So he is the end of the whisker. Okay, so see how I had my two highest data points. They were already outliers. So the end of the whisker for this particular example, right, is going to be labeled with the third highest data point. Let's do the left. It's going to be less work than the right-hand side. So now we got to check this fence. This one is Q1 minus 1.5 IQR. And that gives you negative 389. You could probably have visually seen it was going to go to negative anyway, which means we couldn't have any outliers, but I still need you to show me on a test negative 389 so I can make sure that you use the correct formula, right? So no, we have no outliers on the left. So the end of the whisker on the left really is just the minimum of 242. You can check this fence if you want, but you don't need to. If you don't have any data points falling past this fence, well, you're not going to have any data points falling past the other fence, so I could save myself just a little bit of work. We'll see if there's skew in just a minute, but I want to show you, like in a testing situation, the minimum you would have to show me. I'm about to erase things, so you can pause me if you're not ready for me to erase. That is the minimum. All the pieces labeled here, and then your outlier fence is labeled. But I would always say give me more than the minimum, right? Because if you make a mistake, then all of that's going to be wrong. And if I have no work to check, I'm not going to be able to give you partial credit, right? Now let's look at this and see if we can tell skew. So looking at the clues I gave you, let me look through them in order. The right whisker longer than the left. Well, how do I know? I didn't even do it to scale, right? So, I just literally put lines. Well, that's the whole point. You can subtract, right? 1402 minus 1158.5. That's giving you 243.5. I'm just going to write that really quick, as this is just my scratch work. It's not part of the box plot. That's the length of that whisker. Let's figure out what the length of this whisker is. Sometimes you can do it in your head. These numbers aren't so nice. This is 297. Oh, okay. Well, my right whisker is not longer than the left. So in some sense, just looking at the whiskers would indicate left skew. All right, let's look at it. The second clue for right skew, median to the left. Oh, I did have that. So see, that's a clue for right skew. The whisker is a clue for left skew. Immediately our clues contradict. This is an example of a problem I'm not going to ask you about. Cannot tell skew. This is real data. I never know what I'm going to get until I do it, right? I will tell you this. The good news is you'll be, right after this, you should go do the box plot for the dentist brushing teeth handout. I also have the answer keys posted. That one clearly shows skew, so you'll be able to practice that one. I've also loaded other extra histograms in the Canvas module where the handouts are. I've loaded at least 2, if not 3. Oh, that's a histogram, I'm sorry. There is another box plot at some point. It might be on the partial review. I'm rambling now, sorry. But that does clearly show skew. So you'll be able to get practice for ones that clearly show skew. But this is not one. Box plots. I think that is all. So do make sure. I'm trying to think of the issues that come up when I'm in a classroom and what students are asking me. Oh, I've come up with a couple. I don't care that you're able to put data in order. Like, the data is already in order. You are not coming up with the medians by hand. We are using the graphing calculator to get Q1 median and Q3. Okay, so make sure that you're not working too hard because that would take up too much time on a test. Then you'll run out of time and you'll fail my test. Another thing that comes up, I think, on some homework problem, if an outlier, let's just talk right here. If you had a data point of 3015.5 where he's landing on the fence, he would actually get pulled back to the mild area. Basically, a data point has to clear the fence. It has to make it over the fence, right? If you had a data point of 2087 landing on this fence, he would not be an outlier. He would be the end of the whisker. So just remember, you have to clear the fence. A couple other things that come up in various box plots you might be practicing. Sometimes there's not a whisker. If your third highest data point was 1158.5, well, there's nowhere to draw a whisker to, right? So Q3 and the whisker up here would be the exact same number, so you don't even draw a whisker. I've seen box plots without any whiskers. This usually happens with small data sets that have also a lot of repeated data. What else have I seen? I've seen where the median and Q3 are the exact same thing, and that's really confusing of how to represent that. Some computer software will like make it thicker so you'll know that that's Q3 and the median. When you're doing a test for me, if that happened to be Q3 and the median, well, you could say that, Q3 and the median. You know, you can talk to me and say, hey, I know that this line is representing both. Now, remember, I'm just playing with this right now. This was not part of this original problem. I'm just thinking of all the things that I know may come up in some homework problems. So there are some weird box plots out there. It is what it is. You know, I usually, when I write tests, just grab some real data set I find in a textbook and we just go with it. So, all right, well, that's it for this video. On whatever schedule and organized document I've given you for the semester, I will have told you what homework you should be practicing, but I do absolutely know the first thing you should do is the box plot for the dentist brushing teeth. How long do you brush your teeth for? Handout. And the answer key is posted. So that's a great one to practice right after this. Also, re-practice this one. Make sure you're okay on this one. We'll see you later.